Hi, everyone. All right, today we're back to talk about correlation. For you visual people, this is how it's spelled. Correlation. All right, I'm going to delete that in a little bit because I'm OCD. So, anyways, what correlation is looking at, is there a relationship between two variables? All right, so there can be a correlation and sometimes there's not. So, for example, in class, I gave an example that was there was a study done and it showed that there was a correlation between the amount of ice cream sold and murder rates. So, what that means is as ice cream sales go up, murder rates go up. As ice cream sales go down, murder rates go down. Now, does that mean one causes the other? No, people are not going and eating ice cream and being like, oh my gosh, this sugar high, this is delicious, let me go murder someone. Or someone's going to murder someone and then celebrates with ice cream. Now, I'm not saying all that is not possible. I'm just saying that's probably not what's going on here. There is what we call a confounding variable. So a confounding variable is an outside variable that's not controlled that can influence our study. Here, that's weather. As weather increases or gets warmer, ice cream sales go up. As weather gets warmer, crime rates go up. So there's a confounding variable there. That is exactly why with correlation, we can say that two variables are related and they're correlated, but we can't say that one causes the other. So correlation doesn't mean causation. It doesn't mean one causes the other. Now, so correlations can be positive or negative. I'm going to show you a couple of examples. So this is the example of a positive correlation. See how the dots are sloping upwards on the scatter plot? You can see the two variables here are hours studied versus grade on some exam, right? Now, as you can see, the more hours you study, the higher your grades are. That is a positive correlation. That means as one variable increases, the other increases. The same thing could be said that as our study goes down, grades go down, right? So they increase together and decrease together. That is a positive correlation. Now, how strong the correlation is has to do with how tightly knit these dots are. How close are they to creating a line? Now, on the other hand, you could also have a negative correlation. That's where the slant is going downwards, downhill, right? So in this case, they're looking at age and internet usage, and it's showing that the lower the age, the more internet they're using, or the more internet they're using, the lower the age, right? And you can see that it's a pretty solid negative correlation, but there is some outliers up here, over here. This one's probably pretty close, right? This person over here represents someone who is older but using the internet frequently per week, right? So to give you an idea of how that all works. Now, you could also have no correlation, which would look like a bunch of dots scattered all over the place. All right. So when we're looking at correlation, there's two things that we want to be able to do. We want to be able to create a scatter plot so we have that visual. And we also want to be able to calculate what is called the correlation coefficient. That's basically putting a number to how how close the correlation is or isn't, right? So first, scatter plot. I have some data here on the left. I did a mini study with 18 people, as you can see. And I asked them how many hours of sleep they got per day. That's listed on the left side. And then on the right side is the happiness rating. So this is how happy they are. Now, that is so subjective, like what makes people happy, right? So what I did was instead of having them rate their own happiness, I had them complete a happiness quiz on the internet, which, I mean, that at least it's standardized and objective. Whether it's a great measure or not is we don't really know. Sorry, I'm getting emails in the bottom right corner. Shout out to all you emailing me. I don't know if I can find a way to block that out, but if not, you'll be a celebrity. That's pretty cool. Anyways, So what I was looking at is I want to know if people who get more sleep are happier, because we know that sleep impacts a lot of our hormones and how our brain functions overall. So my hypothesis is that people that sleep more are happier. Now, are we going to be able to make any killer conclusions off of this data? Probably not. It's only a sample size of 18 people. And again, we don't really know about this happiness rating. We also don't know if people actually know how many hours of sleep they get per night. Maybe they got no sleep last night, so they're just telling me 4 because they got no sleep. Maybe they are thinking about this past weekend, like, oh yeah, I got 15 hours of sleep. So maybe their idea of coming up with an average isn't good. Now, these are possible biases that could be present. But anyways, back to the scatter plot. So to get that, you want to highlight all of your data, including the headings. Go to Insert, click Recommended Charts. It will notice that you're probably looking for a scatter plot, so that's the first one that comes up. You can see it says scatter. Click OK. I'm going to change the title because I like to be a little bit more specific. Do people who sleep, no, that's like are people who sleep more happier? All right, now the other thing I need here is some axes titles. So if you click on the graph, you click the plus sign, you can check axes titles. The bottom axis, the X one, only goes from 0 to 16. So it's pretty obvious that that is the hours of sleep. And this is your happiness rating. Now, you can kind of see a line right here. It's going right here, follow my cursor. It looks like it's going to be a positive correlation. How strong, we don't really know. It looks pretty strong to me. So let's check it out. To actually get a number, we need to use the correlation formula. So I'm going to type correlation down here. I'm going to click in the box next to it. Now, to get the correlation, you type in equals correl, or you can go to the top bar where it says formulas and go to formulas, more, and then statistical, and then find correl. But this is my preference. Double click. Now it says array 1, array 2. Array 1 basically means data set 1, and array 2 means data set 2. So I'm going to highlight data set 1, just the numbers. Then I'm going to put a comma and highlight data set 2. You know you did it right if you see in the end both are selected and they're different colors. Click enter. Our correlation is 0.743105. You don't have to be that accurate though, so I'm going to decrease the decimal. It's about 0.74. That is really strong. So correlation falls between -1 and 1. The closer it is to 1, the stronger of a positive correlation is. The closer it is to -1, the stronger the negative correlation. So I'm going to pull up this table. You can see roughly right here, you got this in class. So you can see all of the intervals in this column. So we had 0.74. That falls right in here between 0.65 and 0.99. That means we have a strong positive correlation. So we go back here. This is a strong positive correlation. What that means is, yeah, it appears that there is a relationship between the two. My hypothesis seems to be correct here, that the more sleep you get, the happier you are. The less sleep you get, the less happy you are. So that is correlation in a nutshell. And remember that correlation doesn't mean causation. We can't say that your sleep directly dictates how happy you are. We all know that there's other variables present there. So it just means that, hey, there might be a relationship between the two. All right. Well, if you need any more help on this topic, please reach out to me, and I'll catch you later.